Today we'll be discussing two sorting algorithms, and we would be discussing how these sorting algorithms get an set of data which is unorganized into a sorted order. And we would then, as a class assignment, try and find out the time durations taken for both these sorts and which one of them is faster. The first algorithm which we'll be talking for the sort is called as the bubble sort. It's also called as the interchange sort because you are interchanging two numbers in an array or two values in an array. The way this works is that you compare each element except the last one uh, with the neighbor to the right. I mean, you compare two adjacent elements. If they are out of order, then you swap them. So this puts the largest element at the very end. So the last element when we do this is in the correct and final place. Now what we do is we compare each element except the last two with its neighbor to the right. If they are out of order, we once again swap them. This puts the second largest element next to the last. So we have the largest element at the end, the second largest element adjacent to that, and the last two elements are now in their correct and final place. Now we compare each element except the last three with its neighbor to the right. And this we continue as above until there are no unsorted elements on the left. So the next slide depicts how the bubble sort works. So if you see here, and there is an array which has 7, 2, 8, 5, 4 as the series of number. So 7 is compared to 2, and since 2 is lesser than 7, we interchange 2 and 7 so that 7 moves to the right and 2 moves to the left. So this is the first uh, iteration of the sort. Then we look at 7 and 8. Since 7 is already less than 8, we don't do anything. Then we compare 8 with 5, and since 5 is lesser than 8, we move 5 to the immediate left position and 8 to the right. And the next iteration we compare 8 to 4. Since 4 is lesser than 8, we move 4 to left and 8 to right. So if you see here in the first iteration of this sort, what has happened is that the lowest element in the array has come to the extreme left. Next iteration, we compare 2 with 7, and since 2 and 7 are already in order, we don't do anything. Next we compare 5 with 7. Since 5 is lesser than 7, we move 5 to the left and 7 to the right, and similarly we go on. So as can be seen in 4 iterations, or the number of iterations which we have totally are there over here, what we find is that we have at the end a sorted array, and this sort of mechanism for sorting is called as a bubble sort. This is a sample code for bubble sort. You could use this code, modify it to find out how many times the loop is running, or also calculate the execution time. And we will use that in the class to find out which algorithm is better than the other. The second algorithm which we look at is the selection sort. Let's say we have an array of length n. We search elements from the start of the array to the end and select the smallest element and swap it to the first or the zeroth element in the location 0. I mean the first element of the array, which could be called as the zeroth element in the array. Then we have put the first position, then we go through the from the second to the last position and select the smallest, swap it with the element in location 1, search elements 2 through 9 n minus 1 and select the smallest and swap it with the element in the location 2. Search element 3 through n minus 1 and select the smallest and swap it with the element in location 3. In a nutshell, what we are trying to do is, in the first round, we are trying to find the smallest element, putting it in position number 1 or array position 0. or and in the second round we're finding the smallest among the balance elements and putting in the second position and so on. And in that way what we are trying to get is a sorted array of uh, elements. This is an example analysis of a selection sort. For example, if we have this number 72854, we take the number 7, we compare it with 2, and then with 8 and 5 and 4. What we find is that 2 is the smallest among the entire set of elements, so 2 moves to the extreme left. Then we take 7 and we compare it with 8, 5 and 4. What we find is 4 is the lowest amongst all these elements, so we move 4 to position 2. Then we take the elements 8 and compare it with 5 and 7. What we find is 5 is the lowest, so we move 5 to the third position. And then we take the element 8 and we compare it with 7. Since 7 is lesser than 8, we move it to the left, and that way you see that we have in roughly 5 iterations all the elements sorted. And uh, this is there's this analysis that it takes the outer loop executes n minus 1 time, the inner loop executes about n by 2 times on an average, that is from n to 2 times, and work done in the inner loop is constant, that is swapping two array elements. So time required is roughly n minus 1 into n by 2. So it's n square. So this is a code for the selection set, and what we would like you to do is write in display statement to find out how many times is this loop executed and how much time it takes compared with the same data which we had for the insertions for the bubble sort. So at the end of the session, now I would request you to write your pieces of code and put in display statements and also check the execution times, which we will discuss in the class. Thank you.